Welcome to Innovate Extreme, episode 6. Today on our show, we welcome Ajay Deshkar, a partner at 3D Engineering Automation LLP. Ajay brings over three decades of experience in consulting across various manufacturing domains, including tool engineering, machine design, robotics, academics, and defense. He has guided numerous clients from small businesses to Fortune 500s on their path to digital transformation. Ajay's expertise spans digitization of products and processes through 3D modeling, 3D printing, simulation, and IIoT solutions, along with enhancing manufacturing performance using execution systems and data analytics. His mission is help companies navigate the Industry 4.0 shift to bolster operational excellence, innovation, and competitiveness. Welcome, Ajay, to our show.
Thank you. Thank you very much, Musawa.
So, Ajay, you have a vast experience in manufacturing.
Sure.
So, today we are going to discuss about digital twins.
Mhm.
So, I just wanted to know whether what is digital twin and why is it crucial in manufacturing?
Right. So before going into the discussion about digital twins for manufacturing, I would like to tell you that we deal as an organization deal into three different types of digital twins. And a digital twin, as we all know, is a virtual replica of the product or the space that has to be digitally twinned. And it includes the factory layout, the machinery, the systems, and all of that, and fetches data in real time and sends out information, which is real time again. So, like we are talking about this, the digital twin of the manufacturing or performance, we talk about three types of digital twins. The first is the product digital twin, the second is a process digital twin, and the third is a performance digital twin. So I hope this makes sense. And the product digital twin is what we talk as the actual 3D model of the assembly, where we do the simulation, and it helps us to actually twin the actual part, the assembly, and what is in the 3D model. Then the process digital twin is the entire line where you can see the line balanced, the throughput simulation, and things like that, which is the process digital twin. And coming to the topic of the discussion, which is the manufacturing digital twin, it is the digital twin of the entire factory. So it's like a factory which has got various machines, lines, gantries, material handling equipments, and all. And the information of all of that is captured real time on a dashboard, which will be called herefore as the manufacturing digital twin.
Okay, that's great. Actually, we are also into digital twins, and
Mhm.
we focus on mostly real-time integration with the factory digital twin.
Mhm.
So, how do digital twins integrate with existing manufacturing systems and processes?
So the benefit of using a digital twin is only when you integrate them with the enterprise solutions. For example, when you have a digital twin which is taking a lot of data from the factory and providing you a dashboard of all the information which is collected from the shop floor, then it is all the more important to connect that with your mainline enterprise solutions like ERP, the product lifecycle management solution called PLM, manufacturing execution solutions, and even the warehouse management if there is a automated storage and retrieval system in the workshop. So the connectivity between the digital twin and these systems shall help us not only gain real-time information, but also disseminate information to other departments, which can make more information out of it. For example, the inventory information, the information relating to the costs, and things like that.
Okay, yeah, that's great information. So, with these digital twin, do we connect with some web services or API, or do we connect with uh, some other way like
Yeah, so
OData
the
or
yes, so the digital twins is a very loose term used for a variety of different things. and digital twin can be created using IoT or manufacturing execution systems. But the important factor is it is a decision where we need to take whether this information is required to be on the cloud or on the premise. So if it has to be on the cloud. The good part about having the information of your shop floor on the cloud is that you can access it from anywhere. I mean, you could be sitting on a airport or on the field, and you could from your tab or a phone get an information such as how many people are working, what is the rejection rate today, what is the current machine output and rejections and so on and so forth. So if it is on the cloud, on the prem, most of the manufacturing companies in India have still not come to terms with using cloud, and that also relates to the infrastructural stability in India. But then on-premise systems are also of great use, because at least you go into the factory and be able to connect that through LAN or WAN and get that information on your connected devices.
Yeah, actually, that is the challenge. Actually, I want to give you an example. Like we are in
Mhm.
SAP consulting,
Mhm.
and SAP has launched a new MES called SAP DM,
Yeah.
and that is actually cloud only solution.
Mhm.
So most of the manufacturer not in India, it's but also abroad are hesitant to use it because infrastructure is not 100% at any place in the world at present, and
Correct.
any disconnection will result in uh, downtime at shop floor level. That will be a big problem. So most of the people are hesitant to adopt cloud-based MES systems.
Yeah, that is the problem with with any system, that once you have it, then you get used to it to such an extent that you cannot live without it, and that's a kind of a catch-22 situation here. And it's not, as you rightly said, it's not only relating to India. It's the world over, because the uptime cannot be guaranteed 100%. That is the first thing. The other thing, Musarat, here also is the readiness of a company to give away data on the cloud, where they feel insecure about the information which is on the cloud. They feel that it can be hacked and they can be taken for ransom, for example. And it has happened. So large companies have had challenges such as their servers being hacked, and they've been called from a ransomware attack, and all the data gone, and everything coming to a grinding halt.
Yes, exactly. So cloud is still area that people do not want to go heads on without, at least in terms of manufacturing domain, because that is real time information.
Correct.
So other things can be moved to cloud, but manufacturing they are not right ready. And the
Yes.
best thing is that these companies, SAP started with cloud, and cloud didn't work out, so they came back to on-premise and
Mm-hmm.
named it Edge Systems.
Mm-hmm.
So edge devices, it's just a fancy way of on-premise
Yeah,
system, and they are
correct.
calling it
Correct.
edge.
Correct. So we are partners with Siemens, Musarat, and Siemens being one of the large conglomerates, and having been into the shop floor hardware, particularly the PLCs and the sensors and data acquisition. Siemens acquired a company called UGS, Unographic Solutions, in 2007, and we have been working with this company for about 25 years now. And because of this acquisition, we became Siemens partners. So what has happened now is this stream of Siemens, which is called as the digital software division, has solutions called as Op Center, which connects with the shop floor information through what is
Yeah.
called as a totally integrated automation. And they have Siemens have a very what you can say, a stable solution to for the manufacturing companies. But then obviously there are cost factors which come into picture. There are other challenges, Musarat, in this. That what happens is, we talked about connectivity and data, what you can say, privacy issues. But then there are challenges of what you can say, very high deployment costs, increasing storage costs, and the power costs. as well as availability and retention of trained manpower, for example, is one of the very important aspects, because this system is only as good as you configure, and it's only as good as you use it. So
Yes.
there need to be people who can use it properly.
Yes. Yeah, exactly. So, can you provide an example like how digital twins have worked in a manufacturing settings, and have they provided any benefit in as a solution that you have come across?
Absolutely. So let us take an example of a company. For example, we work for a system in a liquor manufacturing company called Diageo, for example, and they, as you know, they have casks, and these casks are used over brews, and for several years, these casks have a life. Now, what happens in the process is there are thousands of such casks all over, and if these casks are to be giving the quality in the spirit later, then it has to be used in a particular manner, first of all, and the secondly, as many number of times. So it cannot be used for forever. Otherwise, it does not give the quality that the company is advertising. So what it does is, what we have done for them is we have put up a traceability solution for them, and we have QR coded all the casks, and all of these casks, when they are loaded onto the storage system, each of these are what you can say scanned, and then there is a central system which helps us to know how many of the casks are ending their lives in this month, how many need to be replaced, and at the click of a button we know that we can be prepared for what is going to happen with us for the 6 months down the line. The other solution is, what we have done is integration of a warehouse management solution. So it's a company in Noida where it's a automated storage and retrieval system, where we have created a digital twin using plant simulation, where a large 30,000 square feet storage, each of the cell in the storage is now mapped on the digital twin. And when a piece is delivered, for example, is picked up from a particular cell and it goes for packaging, the system gives an alert that we are short on inventory and it needs to be replenished. So many such examples can be given, Musarat.
Yeah, exactly. It's still a new area, and we can think the sky is the limit because of the
Oh,
new tech.
absolutely, absolutely, absolutely. For example, a rickshaw three-wheeler body manufacturer in Aurangabad, they have a setup which gives an entire system of what is the production rate, what is the quantity. For example, if they have to manufacture 800 rickshaw bodies a day, and sitting from anywhere in the world, once you access, you know what is the current status. Are we going to meet the target today? If there are rejections, are they, if there are shortfalls, are they because of the manpower or rejections? If they are because of the manpower, you can take a quick decision to have some temporary manpower deployed there, because it does not need, some of the manpower is not so very skilled. So such decisions can be taken. So these systems, primarily, the biggest advantage is the benefit of taking decisions on the fly, and that helps us to improve the productivity, the efficiency, the overall throughput, and obviously the profitability. So it directly has a complete impact on the profitability of the company.
Yes, exactly. So, we are listening a lot about AI these days.
Yeah.
So, how digital twins leverage IoT or AI technologies to enhance manufacturing operations?
See, uh, the future of IoT is AI, should I say. It's still not there. And as you rightly said, we are still in the process, and it's still some time to go. Large companies have started implementing, and for example, generative AI is one of the future things that is going to come up here, which allows input of variety of prompts into the system, and it generates various information such as texts and images and videos and sounds and things like that. So the most, I mean, applicable use case of this is the creation of training manuals. For example, what happens is, in large factories, at each of the stages, there are various, skilled or unskilled labor which is working. and at times they have to be replenished either because of the increase in production rates or because of absenteeism, and there are festive seasons and there are absenteeisms which happen. So the entire system is now recorded, and new people can come in and start looking at some systems. So if the entire system is videographed, for example, you can actually be trained in real time by using virtual reality solutions which are using immersive technologies. And then of course the AI and ML thing comes in, where you can have what you can say a more in-depth activity where you have taught, or the system has learned from the past several years of data, or past several months of data, and is now giving you alerts that something which is not happening as per the record. One of the important tools that happens here is the application of predictive maintenance. For example, once you have set up a data of what the temperature of a bearing or a particular sensor has been set at a particular threshold, what happens is, if the system starts behaving a little irrationally, it starts giving you signals that you need to have some preventive maintenance. And because you have a digital twin of the entire shop floor now, you can now identify which is that area which needs maintenance. And you can then probably have a pre-planned shutdown or on a weekend and things like that. And that's a great benefit, because if such a breakdown happens during the working days, you lose a lot of time into the entire. And what has started happening, Musarat, is because of all these systems, people have started working what is called as a JIT system, is just in time. So not only do the vendors or the suppliers of a OE, for example, if they, let's take an example of a scooter or a motorcycle manufacturer, and let's say a company which is making center stands for a motorcycle. Now they are supplying per day, and there is no stock. I mean, if there is a there's just a 2 hour gap between what the vendor is supplying and what the assembly on the OE is being done. Now, if the breakdown is happening today, you can imagine the entire value chain gets stuck up. So such systems now put pressure on each of the solution provider to make sure they are up. They are also giving you right results, because without which the entire value chain gets disturbed.
Yeah, I understand, and I really like that predictive maintenance part, because that is something AI can work flawlessly because of the data it will be provided. But the only problem is that data management, because most of the companies do not have that much amount of data that a new AI can be trained.
Correct.
So that is the roadblock that we have to handle somehow.
Yeah.
And
And this does not
so,
only have applications in such manufacturing companies. Applications are, of course, in manufacturing, but manufacturing of automotives, of aerospace components, healthcare machinery, healthcare components, including energy and utility systems like oil and gas systems,
mhm.
retail shops or sports manufacturers, and things like that.
So coming to data management, what types
Mhm.
of data are critical for the effective operation of digital twins, and how should this be managed?
See, uh, there are various ways data can be managed. Now, if that data is pertaining to the manpower, inventory, and the costs, obviously ERP is the solution where the data is managed. If the data is pertaining to, let's say, design, shop floor data, where we have CAM routines being written between the design and the manufacturing, or there is data of let's say shop floor data, then there is a system called as PLM, which is called as the product lifecycle management. In Siemens, there's a product called Team Center, which connects all of this together. Then there is a system called as Op Center, which is primarily the manufacturing execution system, which retains all the information and has apps which can give you meaningful information, which can be customized per whatever application we are requiring. So data management is indeed a big hassle. And first of all, once you start having a data, there are other challenges such as access management, because you cannot have the data. Once you have the explosion of so much of data, there is a problem of how to store that data. Once you have the storage being taken care of, you need to be sure that it is not taken away by someone, because once you have electronic data, you can just copy it on a thumb drive or on a drive, Google Drive or somewhere, and it can just be taken away from the company. So it also has to be encrypted. It also has to be ensured that only the people who are no, responsible enough and having the authority to access those. So there is something called as access control. There is also something which will be called as version and revision management of data. For example, when we are creating a drawing and that drawing has to be released on the shop floor, with the advent of electronic, see, in the earlier days, what used to happen when good old days when Musarat we became engineers, we used to have manual drawings, and manual drawings were all very well controlled. For example, each of the drawing at the right hand corner used to have a table which had physical signatures saying that this is drawn by Ajay, it has been approved by Musarrat, it has been released by somebody called Johnson, and things like that. So when such a drawing goes on the shop floor, everybody knows what has happened in the past. Now, if you have to make a change to that drawing, there is a whole lot of process which is called as the engineering change management. With the advent of electronic drawing, what has happened is everybody has started keeping copies of those drawings on their laptops and PCs and things like that. And one fine day, a person finds some change. He just does that change, not even realizing that that change can create a different version of that. And he's sure that this change is necessary, but that is not going into the shop floor as a meaningful information. So the production continues on the older version of the drawing. So that is exactly where this data management becomes of very crucial importance. And using correct version, correct revision of the data, making sure that the data is stored in a proper way, so it is actually a proper repository of information. This repository of information should have access control. Only those people who have the authority should be able to access that, and so on and so forth. So the data management subject is a large and vast subject. There also are sometimes workflows involved in this. For example, when we have a release of drawing, for example, then there is a set of people who have typical morning meetings. And in the good old days, they used to sit on a large drawing sheet around a table and discuss around it and red marking those corrections which are required. Today, everybody can do that electronically, and then they can just have the approval given in the workflow, and the drawing can be released. So such kind of processes are also there to control the menace that can be created by by misuse of data.
Yeah, actually, a single version of truth is very important
Very,
because,
very important. Yeah.
yeah. So, coming to the future development, what future development do you see for digital twins in manufacturing over the next decade?
So the biggest future that seems to be coming is the accuracy of simulations. For example, right now, even though companies have started using to certain extent IoT solutions or MES solutions, they still have to look at some other data to be sure that what information they are seeing here is right. The accuracy can come because then the real time. First of all, we of course know the speed of internet and what you call as latency, which is one of the more important factors. The future lies into advanced technologies such as generative AI, IoT, and integrated with digital twins all together to give you higher or greater insights into operational performance and give more efficient and effective processes, which will ultimately result into better products and more sustainable future. One of the important aspects of the future also is the carbon footprint of the entire manufacturing. How much power is being used, what kind of savings you can do, also how much water have you been able to save, how much electricity you have been able to save, how much other resources you have been able to save, and so on and so forth. So this is actually endless, Musar. I mean, it can go on forever. but then future definitely lies in giving you more accurate information, and information which is also related to the global warming and self-sustenance of the entire world for that matter.
Yeah, actually, glad that you brought out self-sustenance, because sustainability is the future. We might develop AI and digital twins and all those things, but if they are not sustainable, then there will be no generation, future generations to have.
Absolutely, yes. You said it right. Yes.
So, what are the ethical and security consideration manufacturer must address when deploying digital twins?
See, one of the biggest threat of manufacturing operations using such system is the breach of network security. So, as you know, as I already told you, that one of the important aspects is making sure that there is no unauthorized access to the network, which can disrupt your operations completely. There could be somebody who can steal the data and even remotely shut down the operations of the whole manufacturing facility. For example, somebody coming from the world of hacking and can come and just ask you for ransom or take you for ransom. So the importance of security is very greatly done. Then in that case, what needs to happen is, if there are companies which are having single or multiple locations, there has to be a backup mechanism, and that backup mechanism also has to be having isolations. For example, if you have a server which is on a cloud which is sitting in Singapore, for example, then you need to have a replica of that somewhere else, in the United States or in Mumbai, for example, and make sure that all of these locations are connected in such a way that in any of the cases which is having a trouble, the mirrored database can be hooked on very soon, and then you can get on with the system. As I said earlier, it is important to note that a system, once you get hooked to a system, it is very important that the system continuously gives the same quality of data. Otherwise, the system will be of no use.
Yes, yes, exactly. So, if a manufacturer is interested in developing digital twins, what are the first steps they should take?
Well, the first step they should take is to ensure that their IT infrastructure or their IT policy has been correctly defined. Because what is happening is, most of the manufacturing companies have a very poor insight into IT. And
Yes.
these two, what you can say, things have to go in parallel, like the rail strips, if you like. And there has to be very balanced approach between their own manufacturing facility and the IT policy that they are going to approach. So the first thing that they should do is adopt a proper IT facility. The second is that policy should define what kind of infrastructure that will be required, to be sure whether they want to go on cloud or they want to use the system on premise and things like that. The third thing is they need to have a proper vendor along with them. It is very important to note that no manufacturing company, whatever may they invest, will ever be able to own up a complete system by themselves. They will have to have a partner who will be able to, first of all, implement, own, and operate the whole system. So I think these are the very logical steps to go towards that system.
Yes, I completely agree with this, because many manufacturing companies try to start their own IT department, but the thing is, they do not have that much of visibility into the uh, issues and chances that come across in something complicated as digital twin.
Very
So
true. Very true.
that's why they fail.
Correct.
So how should a company measure the success of or ROI of implementing a digital twin within their operations?
This is a very important subject you have brought up, and it also linked to your earlier question. Your earlier question was, how should you prepare for getting into this digital bandwagon? Is by defining what do you want from the system. And when I say that, you should be able to identify your pain areas and define that these are the pain areas that this system should be able to address. For example, if you are right now blind to some of the informations which are, for example, how much rejection has happened in a day or in a week's manufacturing time, or for example, you have to reduce the total number of hours required for a particular development, or for example, you want to increase the takt time of a particular production, uh, and such things need to be first defined into the preparation of going digital. So once you know what are those top 5, top 10 situations why you want to go into a digital twin, automatically these becomes your measurement indices. So for example, if you have defined that you want to improve your productivity by 5%, or for example, you want to reduce the rejection rate by 3%, or you want to improve the productivity of a cell by 10%. So such kind of measurement indices have to be first defined, because without those indices being defined before the system is implemented, you cannot have the system implemented and then just wait for some miracle to happen, because the system will be designed for meeting the goals that you have set for.
Yeah, companies should know the value that digital twins bring and adopt their plan accordingly. Otherwise, many companies think that it's something fancy and we should have it and it looks good, so they will implement it, but they will not see any results if they do not have a proper plan.
Yeah, I have seen companies where they feel that implementation of a digital twin will solve their problem forever, whereas they need to know that digital twin is only a replica of your physical thing. So, so
Yeah.
the physical thing has to be a well-oiled machine, if you like, to be able to give you a replica, which shall then behave like a well-oiled machine.
Yes, exactly. You said it right. So, coming to the end of the show, so Ajay, could you share your vision for the future of digital twins? How do you see this technology evolving, and what impact do you hope it will have on the industry?
So, first of all, thank you for having me here on this show, Musarrat. The future of this, I think, is where you have an effective process for making better products and being able to address what is called as small and medium enterprises. Because as long as SMEs, for example, don't use this system, the entire ecosystem around the digital twin program will just be limited to large organizations. And the large organizations will keep on growing, but the supply chain, which is depending on these SMEs, will have to improve. So, in my opinion, the future is to start working with where the development starts, which is the small and medium enterprises. So, the future is primarily to make this a little more lightweight. Today, what has started happening, Musarat, is there are no, this has started becoming a little bit of a more jargonous thing, where people have started looking it like a white elephant. And also, some of the people are started to look at it like a elephant in a room with seven blind men, and they don't know what to expect from this system.
Mm,
So
yeah.
if we are able to just lower its or you can say commoditize this a little better by making it as friendly as a mobile. So for example, 10 years back, nobody would have imagined that no UPI would be able to no even entice the rickshaw goer or maybe a sabjiwala or anybody to actually use payment for doing 12 rupees 15 rupees payments. Now
Yeah.
there were quite a few doubts, but the system was made in such a manner that it can be used by no, even illiterate people, people who have very little information about how to use such systems. So my no drawing an analogy from this system, I want to look at a future which is so easy to use and so commoditized in that manner that it can be not only used by small and micro industries, so that it then goes into the entire application zone.
Yeah, actually, UPI has shown that digitalization is possible at the grassroots level also. So,
Absolutely.
actually, small and medium enterprise are the backbone of the economy because, as I was reading a study in US, 98% of the companies manufacturers are from SME only, and
Hmm.
only 2% are big companies. So we have to make these things affordable, or as you said, commoditize it so that
Correct.
everyone can have it in the systems.
Absolutely.
Yeah, Ajay, thanks for taking out your time and uh, being here. And I will be coming to you again with more requests on being on our show. It was a great pleasure having you here, and I got to learn a lot from this session.
Likewise, thank you so much. Thank you, Musharat, for having me on the show, and it will be my pleasure to be talking on some other topic with you on this show.
Yeah, thanks a lot. Have a nice day.
Thank you.
This
You
was
have a nice
Musarat.
day too.
This was Musarat and Ajay signing off.